So now we're on video number 8, and this is going to be the page that says double replacement reactions at the top. Double replacement reaction is going to involve an exchange of positive ions between two reacting compounds. So we have compound plus compound, and so you're going to have cation anion, AB, plus another cation anion, CD. And what will happen is the outsides will get together, so A and D, and then the insides will get together, so B with C, B with C. If it comes first over here, it has to come first over here because cations always come first. So if you'll notice, here we have aluminum chloride plus magnesium bromide. And so aluminum and bromide, first and last, will get together. And then we get aluminum bromide. And then I like to say third and second get together. So it's going to be first and last, third and second. So the first and the last plus the third and the second are going to get together. So double replacement reactions are outside, inside, and cation before anion. For double replacement reactions to occur, one of the following is usually true. A precipitate is formed, so a solid comes out of the solution, or a gas is produced and bubbles out of the solution, or one product is a molecular compound, H2O, water. To determine if a reaction forms a precipitate, we're going to use solubility rules, and these are going to be provided for you from the STAR references. So we look at each product form in the reaction, and if the product is soluble, then that means that it dissolves and is not a precipitate. If the product is insoluble, that means it is not able to dissolve, so it is the precipitate. Big exclamation point there. Highlighted insoluble for you is when you have a precipitate form. Practice determining when is a compound soluble or insoluble. Predict whether or not these compounds are soluble in water, and we're going to put a yes or a no. We're going to go look at the solubility rules to determine this. So first is calcium iodide. So we need to look at this list over here, and we're going to look for the anion, which in our case is the iodide, which is found under soluble. So any compound that is an iodide compound, such as what we have here, calcium iodide, iodides are soluble except if this metal happens to be silver, lead, or mercury, and then it's the opposite of soluble, it becomes insoluble. But since calcium is not one of these exceptions, then this compound is considered soluble. We'll come over here, compound soluble, and I'm going to write soluble, or yes would be sufficient. All right, let's look at magnesium sulfate. Again, go to your chart at the top right, and I want to find sulfates here. And you'll notice that sulfate is found under the soluble column. So sulfates are soluble except when they are with strontium, barium, lead, or mercury. And our compound is magnesium sulfate. So since magnesium is not one of these exceptions, this compound is soluble. I went back to my list and I marked magnesium sulfate as soluble. Now let's look at aluminum phosphate. Go back to our list, and we're looking for, and you're always trying to find the anion. So our anion is PO4, that's phosphate, and I don't see PO4 in the soluble list. So now I'm looking at the bottom where it says insoluble, and remember, insoluble is going to be when you form a precipitate. So notice PO4, there's my phosphate, PO4, it's right here. It is in the insoluble column, and so now I just have to check for the exceptions, and so I'm looking for aluminum in the exceptions. The compounds of ammonium and alkali metals. Now alkali metals are in group 1 on the periodic table, so here's group 1, and you'll see aluminum is not one of these. Aluminum is over here in group 3, so this is not an exception. So phosphates are insoluble, and so this is insoluble. That means that if this were one of my products, it would be considered a precipitate. So here I've labeled aluminum phosphate as insoluble. Now let's go look for lead nitrate on our list. So nitrate, remember you want to look for ions in your anions in your list. So I'm going to look over here, and under the soluble column, there's nitrate. So it is a soluble compound, and let's see if there are any exceptions. There are no exceptions. So since this is a nitrate, it is automatically soluble with no exception. And now I've written soluble here. Let's go look for silver sulfate. So I'm looking for the anion in the list, so SO4. Let's look under soluble. And it's at the bottom. There is SO4. So it's soluble unless we have one of these metals with my sulfate. So if this is strontium, barium, lead, or mercury, then it's the opposite of soluble. It's insoluble. But since silver is not an exception, this is soluble. I wrote soluble there next to silver sulfate, and my last example is calcium hydroxide. Let's look under the soluble column, and we are focusing on hydroxide, OH. So I don't see hydroxide in the soluble section, so that must mean it's down here in the insoluble section, and sure enough, there it is right there. So this is an insoluble compound unless this calcium is one of the exceptions. Compounds of ammonium, the alkali metal cations, or calcium, strontium, barium. You see how calcium's an exception? So it would have been insoluble. Now it's the opposite. It is soluble. So this is going to be a soluble compound. Because calcium is an exception, it's no longer insoluble. It becomes soluble, the opposite. This will complete this chart of is it soluble or insoluble. So which of these could have been labeled a precipitate? The only one you can label a precipitate is going to be this one right here because it is insoluble. Everything else that is soluble cannot be a precipitate. Okay, here's the last part, and this is the most challenging. Have to predict the products of these double replacement reactions. You're going to need your periodic table reference chart, your polyatomic ions reference in order to balance charges. So first, it's going to be first, which is copper, and last, which is just what is in the parentheses, the NO3. Don't bring the 2. So we're going to write NO3 there. So first with last plus, separate it with a plus, and now it's third and second. Third is barium, Ba, and second is all of this, the SO4. That's our sulfate, SO4. Okay, now that I've predicted my products, I have to balance the charges. And I'm going to use a pencil just to write our charges in. Over here, I need to know what is that charge of copper. And to figure it out, I got to look up what is the charge of sulfate. So here's sulfate, SO4, has an overall -2 charge. So here I'm going to write that SO4 has a -2. I only have one SO4, so we have an overall -2, which means that I need to have an overall +2 to balance that. And since there's only one copper, it must be a +2 charge. So this copper is a +2. That is the box method that you may recall from Unit 6. Now, let's go look up the charge of nitrate, which is NO3. So when I look at my list, here is nitrate, NO3, and it's got a -1 charge. So this has a -1 charge. When we take our charges, we're going to have to crisscross them to balance. So this means this has a subscript of 1, and the nitrate needs parentheses and a subscript of 2. Okay, barium is on the periodic table, and it has a charge of +2. And then the sulfate, we already looked it up, has a charge of -2 in our list. +2 and -2 cancel, So you're done. You don't have to do anything with this. When we're finished, we should erase the charges because we don't need them on our final answer. It's just copper nitrate plus barium sulfate. Once I crisscross or cancel charges, then I'm done with them. And then you're going to balance the coefficients. So here you have a 1 copper, 1 copper. Remember, we can treat this as a bundle. 1 sulfate, 1 sulfate, 1 barium, 1 barium, 2 nitrates, 2 nitrates. So this is actually balanced with 1, 1, 1, 1 coefficients. Okay, let's look at the next one. It's going to be first and last. So copper, and then last is hydroxide, and then put a plus sign. Third, which is the sodium, and second, which is SO4. And now I have to go balance the charges. Notice here, same thing as that first example, this sulfate was -2, and we already figured out mathematically that that copper's got to be a +2. So over here, this copper is a +2, and if you look for hydroxide on your list, here it is. Hydroxide OH has a -1 charge, so -1. And now I need to crisscross. I need a subscript of 1 here, and I'm going to need a 2 over here. And now these charges are balanced. Over here, sodium has a +1 charge. And we should know by now from the last problem that the sulfate, SO4, has a -2 charge. So if I crisscross, I'm going to get a subscript of 2 here. And then I can erase my charges because I don't need them anymore. I only needed them to figure out my subscripts. And so this would be my equation. Finally, you would balance the coefficients. So you'd have a blank here, a blank here, a blank here, a blank here. 1 copper, 1 copper. I'm going to treat sulfate like a bundle. 1 sulfate, 1 sulfate. This has a 2 in front of it already. So we have 2 sodiums on the left. That is 2 sodiums on the right. And then finally, this is my last bundle. We have 2 hydroxides on the left, and this means I have 2 hydroxides on the right. So this is balanced as a 1, 2, 1, 1 ratio. Okay, the next one, we're going to put first with the last. Don't bring the 3, don't bring the 2, just put the elements. K, Cl, first, last. Separate them with a plus sign. Third and second. Third is Mg for magnesium, and second is PO4, that is phosphate. Now I need to balance the charges. Let's go find K and Cl. K is +1 and Cl is -1. So +1 minus 1, and +1 minus 1 will cancel. So I don't need to do anything. Leave it alone. Over here, let's go find magnesium. It is a +2. So I'll put that there. And then PO4 is on my list of polyatomic ions. PO4 is here. It has a -3 charge. So I'm going to put my -3, and then we have to crisscross the charges. That means I'm going to get a subscript of 3 here. This means I'm going to have a subscript of 2 there. And then once I finish that, I don't need the charges anymore, so I'm going to just erase them. And there are my products. In order to balance the equation, coefficient, 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 we have 3 potassium on the left, but only 1 on the right. So I'm going to put a 3 here. I'm going to bundle this together, 1 phosphate here, but I have 2 phosphates here. So to fix it, I'm going to put a 2 there. That has modified my potassium, so I'm going to go ahead and fix that now. 2 times 3 is 6 potassium, so this is actually going to be 6. So 6 potassium, 2 phosphates, 2 phosphates. Now magnesium, 1 magnesium, 3 magnesiums. I'm going to put a 3 here. And then finally, 3 times 2 is 6 chlorine, and lucky us, 6 chlorine, that is already balanced, so this is 2, 3, 6, and 1. Final example. We want to take first which is sodium, and don't bring the 2, just put sodium. And then last is SO4, that's sulfate. Put that here. Separate them with a plus sign. Third is K, potassium. And second is CrO4. CrO4. Now, I need to balance my charges. I'm going to go find sodium and potassium because they're both in the same family. So over here we have sodium is +1 and potassium is also +1. So +1, +1. And then in your list of polyatomic ions, sulfate or SO4 is here. It has a -2 charge. And chromate, CrO4, is going to be up here, CrO4. It also has a -2 charge. So -2, -2. Now I'm going to crisscross my charges. So we're going to have a subscript of 2 here and a 1 there. And then the same thing here. I'm going to have a subscript of 2 here and a 1 here. And so now I'm done. Remember, if you only need one polyatomic ion, it does not need to have a set of parentheses to go around it. That's only if you need more than one polyatomic do you need parentheses to go around it. So finally, let's balance the equation. Put my blanks here, here, and here. We have 2 sodium, 1 chromate, CrO4, 1 chromate, 2 potassium, 1 sulfate, 1 sulfate. So this is balanced with a 1, 1, 1, 1 ratio. Okay, I'm going to use my highlighter because the very last thing I need to do is identify what is the precipitate that was formed. And so I'm going to look at my products and I'm going to go to my list of solubility rules and we're going to figure out which one is insoluble. So a little reminder here, what is insoluble? And if it's insoluble, it's going to be a precipitate. So let's see, this is nitrate, NO3. Here's nitrates. It is always soluble with no exception. So that's not a precipitate. Let's look at barium sulfate. Sulfates, SO4, are always soluble unless they have barium. There's the exception. So this is going to be a precipitate because it is insoluble. Okay, let's look at copper hydroxide. And hydroxide is there. It is insoluble unless copper is an exception, and copper is not an exception. So that is insoluble, therefore it is my precipitate. And I'm just highlighting the precipitates. Okay, next is potassium chloride. I'm going to go find chlorides, which under the soluble column, there's chlorides. And is potassium an exception? No, it's not. So this is a soluble compound, not the precipitate. Magnesium phosphate, PO4. I'm going to go look under my list. It's not in the soluble. It's here under insoluble. So it's going to be insoluble unless it's with ammonium or an alkali metal, which magnesium is neither. And therefore, this is going to be insoluble, and so it is our precipitate. Sodium sulfate. I'm going to go look up sulfate, which is there. Is sodium an exception? No, it's not, and so this is soluble. Okay, so that's soluble, not the precipitate. And then let's look at this, potassium chromate. So CrO4 is here. That is insoluble unless we have potassium over here, and guess what? Potassium is an alkali metal because potassium is found in group 1 on the periodic table. This is the alkali metal family. So that means that neither of these can be the precipitate. And so you can actually say that here no reaction occurs since we don't get anything, no precipitate for the product. So this one would be no reaction because we have no precipitate. But these three, the highlighted, are the precipitates that formed. Remember, use your rules, and if it's insoluble, then that is the precipitate. Now you turn to page 18, and you're going to do homework part 6. And a video will be posted of the solutions of that homework.